Hello, AP Environmental Science students. Today we're going to continue with Chapter 3, which is Ecosystems. What are they and how do they work? All today's notes are based off of Living in the Environment, the 16th edition by Miller and Spoolman. So our biology review is going to continue with this section. This section is entitled, What Happens to Energy in Ecosystems? So the two main ideas here are that energy flows through ecosystems in food chains and webs, and that as energy flows through ecosystems and food chains and webs, the amount of chemical energy available to organisms at each succeeding feeding level decreases. So you guys are all aware of food chains. You guys have been doing these since you were probably 10. And food chains are just a sequence of organisms, each which serves as the food source of a source of food or energy for the next. So again, remember, this is something that my freshmen always mess up, that the arrows show the flow of energy. So if you look at our diagram here, energy is going from the sun to the producer, from the producer to the herbivore, and so on. You'll see this diagram here is a little bit more complex than something you probably saw in bio, because this one includes the loss of energy as heat, as well as decomposers. So all of these guys are being eaten once they die by decomposers or detritivores. Then we have our food web, and a food web is just a complex network of interconnected food chains. So we could pull out individual chains from this web and look at them just like we did at the one on the previous slide. So each trophic level contains a certain amount of biomass, and biomass is just the dry weight of all organic matter contained in an organism. In a food chain or a food web, chemical energy stored in biomass is transferred from one trophic level to another when it's eaten. This transfer is not super efficient because a lot of the energy is degraded and lost to the environment as low quality heat. And we call this ecological efficiency. And that's just the percentage of usable energy passed through each trophic level. This percentage can range from 2 to 40%, but we often use 10% as our average. So this, from bio, is that 10% rule. So 10% of energy is passed on to the next trophic level. This means that 90% of the energy gained by a trophic level is lost as heat. The pyramid of energy flow is just a diagram that represents the flow of energy through each trophic level in a food chain or food web. The more trophic levels there are, the greater the energy loss. So that's why we usually only see a pyramid with like 4, max 5 levels, because after that, things are not energy efficient. We're not getting enough energy or nutrients from the food that we're eating. So this explains why the earth can support more people if we eat at lower trophic levels, like vegetarian, as opposed to having a bunch of meat eaters. We're not losing all this energy in the process of creating meat for us to consume. So probably the only new thing in this section, and this is actually kind of a difficult concept, we're going to do a lot of work with this in class, is the difference between something called gross primary productivity and net primary productivity. Gross primary productivity, or GPP, is that rate at which an ecosystem's producers convert solar energy into chemical energy as biomass found in their tissues. We report this in the units of kilocals or kcals per meter squared per year. So this is going to be the total energy given to our producers by the sun. Net primary productivity, or NPP, is the rate at which our producers use photosynthesis to produce energy minus the rate of energy used for respiration. So the equation is NPP is equal to the GPP minus R, where R is the energy used for respiration. So in other words, this is basically how much energy is left in the producer's biomass to pass on to the next trophic level after plants use what they need to stay alive, grow, and reproduce. So what energy is left over after the plants use what they needed to from photosynthesis.